Welcome to the pre-calculus video for skill number 7. I can model with linear equations and linear inequalities. And the trivia question for the video is, featured below is a map of a famous empire from the we'll say this map was in 1580 or so, around the Mediterranean Sea. What is the name of the empire that existed in the yellow area of the map? Alright, example 1. Mr. Benches purchased a building that cost $650,000 because I have a lot of money to spend. Unfortunately, the property loses $15,000 in value every year. That's a bummer. What you are to do is to write a linear equation giving the value of y of the building in terms of the years x after the purchase. Sketch a graph of the function and use your model to determine in how many years will the building be worth $500,000. So, what I did is I first said let y be the value of the building. The problem stem told us that. And let x be the years after the purchase. And I created a model. Now there's a couple different ways you can create a model. I logicked my way through it. I said, hey, I'm starting at $650,000 and every year I'm decreasing at $15,000. So if I plug a value of 1 in there, it'll go down 15,000. If I plug a value of 2, it'll go down 15,000 2 times, etc. And I checked my model with a little table off to the side, which we can see. And this table was a good tool for me to say, oh, it looks like I set up my linear model correctly, because I can see that as time passes, the value is going down. I'm losing money on my investment. I invested poorly. Part B, I was asked to sketch a graph, so I sketched a very rudimentary graph. I just created the axis, and then I drew a line that's going down. I called out where my start value was. If I wanted to start to make the graph more accurate, I would give a x value of 0, and we go all the way out to some value of x. We could say that the slope is down 15,000 for every 1 unit we go over. But the sketch I've drawn is basically all I'd want for the idea of sketch a graph. And in part C it says, in how many years will the building be worth $500,000? So I set my equation equal to $500,000 and I solved for x. So in the first step I subtracted 650,000 from both sides and found this to be the equation that resulted. And then I divided both sides by negative 15,000. Negative 15,000. Cancel the zeros. And we wind up getting an answer of 10 years. Oops. So in 10 years, the building I just purchased will be worth $500,000. It would be wise of me to sell it before it loses too much value. So linear models can come in lots of different forms, and so it's somewhat difficult to give you enough examples to show you all the different forms they can come in. So I've provided some general tips to help you in linear modeling. Can you draw a rough sketch of what's happening? My building value went down, or perhaps over time the dollars per hour I get paid will go up. Can you make a table to help you understand? So we just create x, y, and I input my values, and I know that I started at $8 an hour, and then the next time I was at $10 an hour, next time I was at $12 an hour, next time I was at $14 an hour. So creating a table can help you possibly understand what's going on. And I say that often it's easy to start with the slope-intercept form, which is what we had with the last problem, or close to the slope-intercept form. And those are great for problems where they tell you the initial condition. At time 0, we had a property that was worth $650,000. At time 0, we started at $8 an hour. So you can plug in your initial condition, and then you have to figure out how big the change is. And the last problem said we lose $15,000 every year, so that was how big the change was. Here it looks like we're gaining $2 every year. So that's a great form for problems that call out the initial condition. However, if you don't have an initial condition but have 2 data points, the point-slope form is a great tool for modeling. And we learned a lot about the point-slope form in class the other day. So what we can do is use this model, and it's great if we have 2 data points, and the next example shows exactly that.
Hey, Ron.
Hey, Billy. That hurt.
Example 2. The population of the world in the year 1804 was 1 billion. The population in 1927 was 2 billion. Create a linear model to predict the world population. Use that model to find what is the population in 2014 and in 1492. And then why does this feel wrong? All right, so what I did is I set the year as the x variable, so input the year, and output population. And I took my 2 data points. In 1804, the population was 1 billion, and in 1927, the population was 2 billion. And as I said, if you don't have an initial condition, maybe the point-slope form would work for you. So I've got the point-slope form written down here, and I want to start plugging information in. So let's start with the slope. I calculated the slope from my data points, and for those needing a refresher, slope is y2 minus y1 over x2 minus x1. So I plugged those values in, and I got a slope for my slope equation, or point slope equation. And then I went about plugging the values in. I chose the first data point, and I plugged my y1 in, my x1 in, and then my slope into the equation. And I rearranged it so that it was a slope-intercept equation, just because that's oftentimes the easiest one to evaluate. This is my linear model. The answer to part A is the linear model. In fact, this would have also worked as a linear model, but I'm going to use this one to move on to part B. Part B asks for the population in 2014. So I'm just going to plug 2014 in for my variable, and I evaluate that out, and it says in 2014 the population is approximately 2.707 billion people, which seems like an undershot. We do the same thing for 1492, and we plug it in, and it says the population of the world is negative 1.537 billion. And suddenly we start to panic because something is wrong here. The world population right now is over 7 billion, and our model says that it should only be 2.7 billion. And furthermore, negative population, that's not even possible. What's going on? 1492, Columbus sailed the ocean blue, so we know that the population of the world was at least 1, and I'm sure he had lots of people on his boat. So the model is obviously broken. Negative population can't exist, and our world population is over 7 billion. So maybe, just maybe, a linear model was a bad idea on this problem. Later on in the year, we'll talk about other types of models that would probably serve this problem better. but I wanted you to run a linear model just so you can see that sometimes not all things behave according to lines. All right, this concludes skill video 7 for pre-calculus, and the map featured below is the Ottoman Empire in 1580.